Hi, my name is Renato. As I already said, I'm the principal cloud architect for Funable, a provider of a white label cloud solution. And today I would like to discuss a bit how to run relational database and specifically MySQL on the cloud, on the public cloud. And we'll use as example AWS, but you can actually do that on whatever provider you want. When we come to a conference like today, to an event like today, there are many words, many topics we'd like to discuss in a DevOps environment. We talk about orchestration, we talk about serverless, we talk about highly available system, we talk about autoscaling, infrastructure as a code. Last year, of course, Kubernetes everywhere, storage online, serverless. There's one topic we talk a bit less is relational databases. And the reason why we're not usually super excited about relational databases is that they're usually not that great. They are usually the bottleneck of your system. They're usually the part of the system that you talk less about, that scales less, and the one where usually you have the problem. Sorry. When you think about just simply a basic MySQL server, a single instance running of your database server, you have to think about many limitations. You have to think about many related to the specific product. For example, you can think about connection limit. Whatever you scale on the cloud or not, you have to set up certain property. You might have to set up in your MySQL max connection or whatever else. You might need to change it. You might need to think as well, even if you have your Docker containers or your autoscaling group of instances in front of it, at some point, if behind us your relational database, the networking to that database might be your bottleneck. Or maybe the bottleneck is provisioning issues. It might be that, for example, you still run your database and you allocate some storage, and at some point you run out of storage, you need to provide more storage. How are you going to do that? And of course, you have scaling issues, because unless you start to play around with sharding and cool stuff, well, you can scale on the cloud easily vertically. You can change the instance type you might use. You can change the size of the virtual machine, but you cannot go that far with that. And as well, usually when you think about relational databases, it's not something that is easy to integrate in your, when you think about, for example, infrastructure as a code, when you think about integrating that stuff in your Terraform or CloudFormation or whatever you use to describe your environment and to keep control of your environment, it's not that easy to describe the real nature of your database. Yes, you can describe certain aspects, but it's not natively part of it. So which option do we really have when we run on the cloud? Well, even if you think about the largest cloud provider, if you think about Amazon and AWS, it's, I don't know, many years now, is basically every single reInvent, they talk about how cool it is to do things like blue-green deployments or whatever you want on the cloud, and how many options you have to scale your environment, to deploy new version, to do whatever you want. But what impressed me of this kind of presentation usually is out of 55 minutes of a presentation, 50 minutes of describing how cool you can do your front-end, back-end, load balancer, Route 53 for doing DNS, whatever you want to do. Then when you have to play with the database, you're back to the problem of how you migrate the data, how you keep data in sync. And there are some challenges there, and we'll see a few of them in a second. So now, as I said, in this presentation, I'm going to cover mainly the offer of AWS. But of course, some of the services might be similar, might be slightly different, but the same concept applies to the major cloud provider, and as well some private one and some local ones. It's basically a basic general patterns on the topic. So if you think about MySQL and AWS, you have basically three major options, or you used to have three major options. So think about option number one is you take care of yourself of your database and you install it on a virtual machine, so EC2, or you install it on Docker or whatever you want, but basically you keep full control of it and you just use the cloud to provide the hardware. Second option is to go with a native service, something that the cloud provides for you, something like, in case of Amazon, is RDS. In that case, the cloud provider manages the database for you. And the third option is usually go with something that is a fork of a major database, something like, in case of Amazon, is Aurora. So something that It's not anymore the open source standard version of your relational database. It's something similar, maybe not that different, but it's something else. And with each one of them, you have some benefits. So let's start with the basics. First one is, of course, you can run your own MySQL server on EC2 or on your container, wherever you want. In this case, you have a full control of the database. You install whatever you want. You rely on EBS, so on some volume that you define yourself, where you store the data. Of course, you have full control. You have a root access to the database. And you have full flexibility because you can do whatever you want. Very main benefit to have it on the cloud is, of course, you can do some vertical scaling because, of course, you can increase the size of your memory, CPU, whatever, according to the traffic. But there's not much you can do about that. That's the only thing you can do. You have to, of course, take care in production of your own replication, whatever you want to do it synchronous, asynchronous, whatever you want to use, you have to do it yourself. You have to take care of backups, as well. How to manage the failover is still part of something you have to do. And with that flexibility comes as well some benefits. Of course, you have full control, so you can decide to install the latest version of MySQL. You can install something that is a release candidate. You can install whatever you want that you cannot do with a managed service. You can as well install a different distribution. For example, if you love to use Percona, or if you want to use a Galera cluster, that's the only option you have. You have to manage it yourself. So that's quite simple. So if you have your backend instances talking to your database, as a minimum, you'll probably have a master, a slave, some read replica somewhere, and you manage it. So far, so good, quite easy. Second option you have until now was use RDS. RDS for MySQL. It's basically a managed and scalable MySQL. It's a managed service. What does it mean? It means that the cloud provider, Amazon, is doing most of the operational tasks for you. It's not a new service. It's been around for almost 10 years now. It provides, again, simple vertical scaling that you can change the instance type you want to run. So far, so good. But it provides some extra feature that, of course, made it very popular. First one is asynchronous replication. So you don't have to think about the complexity of managing yourself, synchronization, or having a passive master, manage the failover, do anything like that. They do it for you. It's just one API call, a click of a button. You have a passive master running. It's synchronous. The failover is managed to a CNAME. So far, so good. Nothing difficult. And as well, they take care of the backup and point-in-time recovery for you. In the sense that you can have daily backup, you can decide to recover your database to a specific point in time. Stuff that used to be in the hand of just the DBA, and now as well a developer can usually do. Of course, we are talking as an example, because we'll see later on a few examples with Aurora about MySQL, but actually there are other engines available for RDS, Postgres, Oracle, SQL Server, I don't know, even MariaDB. And of course, for each one of them, there's a limitation of which version are supported. Of course, if a new general available version is out, most likely it takes a few months before it's available as a RDS service. But usually that's what you have. And you have extra services like Performance Insight that allow you to do some advanced monitoring or some troubleshooting, see which queries affect badly your database in production, without having really a high level of expertise in managing a database. But still, here you're still managing your database in the sense that when you create a new RDS, you still have to say how big you want to have your storage. For example, you want to allocate 300 gigabytes, you want to allocate 1 terabyte, and you pay for that allocated storage. So you decide in advance what you need, how many IOPS you need for your read and write. So there's still something that is not really on demand. So if we look behind what we saw before, is like basically you talk to RDS in this case, and you don't think anymore where is the passive master, where do I have to do the failover. You just talk to a CNAME, and if something goes wrong, you hope that Amazon is going to recover the database for you and do the failover for you. There's still a third option that is something that more recent, or a few years ago, is Aurora. Aurora is basically a fork of MySQL, originally only for MySQL 5.6, now as well 5.7. And it's basically built for the cloud and fully managed. What does that actually mean? It's something that is, at the moment, just for MySQL and Postgres. Provide, again, vertical scaling as RDS provides, but yes, some other benefits. Well, first of all, it's a proprietary technology. What does it mean is that they started with 5.6 of MySQL, the open source one, but it's basically a fork where they changed the way the storage works. They automatically allocated the storage, so that means that you start your database, you say, I start to use it, and in increment of 10 gigabytes, they allocate the storage as long as you need it. So you don't have to think anymore, that's already one step forward, to think about how much storage I need, and to do the operational task to manage yourself or to create certain alarm to notify you and then trigger a change and how to manage the downtime when the change happens. And then they added extra feature on top of it, something like, apart from performance benefits, apart from not having any more passive master or the logic of a standard or synchronous replication, but having more that the data is replicated in 3 different other AZ and basically 6 copies of your data, and how it's done behind the scene is basically relevant to you. But also they added this other feature to simplify the operational running of the database. For example, backtrack is basically something that we said before that you can do even with RDS. You can go back to a point on time, but technically what it happens is you're starting a new instance in that specific point on time, then you have to change the CNAME, point to the new database, and you might have to do a few operational tasks, and usually when you have an outage, it's not really what you want to do. In case of backtrack, is basically they tell you, you do a mistake or something happened in production, you want to go back 2 hours, you say, I want to go back 2 hours, you might have a downtime while the data goes back, and basically behind there's no real magic, it's again going through read logs or whatever, but they do it for you, and you go back in time. And now they have as well in preview a version with a multi-master, so here, I mean, it's basically a new version of MySQL with some new features on top of it. Those were the 3 main areas that were available until today. But how does this affect automation? Because that's what we would like to have. I mean, ideally, I would like to have that my database scales and my database behaves like my autoscaling group of EC2 instances or my AKS or whatever, that I don't have to think about it, and it scales up and down according to what the traffic of my website or what I really need. So let's think a very simple scenario on RDS or on Aurora. Let's think, can you really scale? We say that one thing that you can do, even with a simple virtual machine or even with RDS, with Aurora, you can scale up and down vertically. Okay, we know that vertical scaling is not the best thing in the world, has many limitations, but still, you might have benefit that according to the traffic you have, you might want to go up and down and provision less resources to your machine and basically pay less when you don't need it. So instead of size your system for just peak load, you size it according to forecast or according to the usage you have in specific time of the day. So, well, it's quite simple. You might think, okay, I can create simple alarms. In this case, I'm using CloudWatch. I create certain alarms that say, okay, if my CPU is above, I don't know, 50%, 60% for a certain amount of time, I put some value there. Like in this case, I think I put 15 minutes. I might trigger an event. And what does it mean? It sends a notification. I have a SNS, and that one triggers a Lambda function. That's quite something really easy. You can do it from the console. You can write a simple Lambda function. You can even do it in Bash using the command line and do a cron job. And that Lambda can trigger a scale up of my database. So that's quite easy. I mean, 3 lines of code, and I can have my database scales up and down. And of course, I don't have to do it just for the CPU. I can do it if I want as well. We said before that what happened when I run out of storage on RDS, because RDS doesn't provision the storage for you. Well, I can create an alarm that if, I don't know, if I'm below 20% free, send me an alarm and either notifies me or trigger a Lambda, and again, I can double the storage. And again, if the database is multi-AZ, if there's a passive master, I can do it with a minimum downtime. So far, so good. But is there really an autoscaling? Is there something really that is automatic? I tend to call it fake autoscaling. The reason is you can do it on many things. You can do it, as we said, we can do it on storage. We can do it on the CPU, we saw. You can even do it on other metrics, because any metrics you have, you can say set certain thresholds. So you can say, well, my database has specific write IOPS or is heavy on read or whatever, it can trigger certain action according to specific thing that happen in my database, or even the latency. If the latency is above, I don't know, 200 milliseconds, I want that my database scales up because whatever. And I can do the opposite. I can say as well, scale down if the metrics are below certain thresholds. And I can do it, of course, using Lambda. I can do it with any SDK. I can do it with the command line. But you might even wonder, why are those tools not available? Why there's not a basic autoscaling on RDS? Or why there's no autoscaling for any database out of the box? Well, reality is that it's not that simple. It's that when you scale a database, you basically stop the database, so your connection pool goes, your cache goes, and you might have even many problems when you change your storage. You'll see a few of them in a second. So it's not that straightforward how until now you could change automatically RDS. So think of as well, what's the role of the database administration in all this? This is a slide from a presentation from Amazon, I think it was a blog last year or 2 years ago. I don't fully agree with every layer, but it's kind of interesting how they present that definitely the role of the database administrator went from running on premises, as well running on a EC2, a database, from more than managing the platform to more managing the application and database layer, leaving the heavy lifting of the platform access, monitoring, whatever else to the cloud provider. And that's definitely good. But what happened? How can you really act when something bad happens? And how can you automate that part? Well, I think something bad happened or something great happened because maybe your website has a peak on demand that you didn't forecast, but it's still good, and you want to actively serve that traffic. Or maybe your database has a problem, a new version that you throw in some bad queries or something goes wrong, and you have to act on that. And you might want to, hopefully, you want to act in a kind of automatic way. You don't have to act just manually. I mean, of course, you can act manually. You can go on the console and you see a huge long list of things you can change. And probably when things go wrong, you might want to change more than one at the same time because you don't know what you're doing. So think about the worst case scenario. Think it's 3 a.m. in the night or whatever time is the worst time for you to be badly affected by a database downtime. Your CTO or someone from management is calling and say, what's going on? Users are complaining. And you might think, okay, the easy way is what we saw, an automatic script that scales up my database, or even do it manually at that point. I go to the console, I go to the command line, I just trigger a modify instance. Very quick. I can even say it's low cost because I might scale it up just for a few hours or a couple of days or whatever I need while I address the problem. It's almost too tempting to click that button or to scale that way. And what can go wrong there? Well, first of all, we have to realize that behind the scene, whatever you use Aurora, whatever you use RDS, whatever you do it yourself, still there's a relational database running. And the moment you start to trigger modification, or mostly if you trigger more than one, the database, from your point of view, you're basically just handing control to the cloud provider, to Amazon in this case, and say, please modify this database for me. And how long that takes is really not out in your control. It might take a few minutes. It might take a few hours. It might take whatever it takes according to how much traffic you have on your website. I will see a better example in a second. And not always you can change it back and scale it down, because we did the example before, say, okay, I run out of storage. Usually as well, your IOPS on the storage depends on the size of the storage. Even if you do provision IOPS, there's a certain limit you can reach with that is 10% the size of your drive. So you might need to increase the storage. But yeah, it's very easy to increase the storage. It might take a long time, but it's still easy. But you cannot easily scale it down. So if you double the storage, you're going to pay for the double storage until you need it. Until you scale down, and to scale down, you basically need to do a dump on the entire database and go to a smaller volume. And you're still paying for it. You might trigger multiple changes because maybe you're not really able to figure out what's going on, or maybe there's really a big peak on usage, and you want to scale, change both the instance type and the IOPS you have on the disk, or change the size of the drive itself. And you trigger multiple changes, but those multiple changes are not actually happening simultaneously. And it's pretty hard to predict what is going to happen first. It's not written in any API. You might test it and see what happens first, but it's not guaranteed. And you might even have multiple failover, because the way it happens is, I'm always assuming that you're running a multi-AZ RDS in this case. So you're in a production scenario where you have an active master and a passive master. So technically what happens is the change applied to a passive master, then there's a failover, changes to the new master, and so on. Well, if you change multiple things, doesn't mean that they apply all the changes first to your passive master and then do a failover. They might apply the first change, do a failover, apply again the second change, do another failover. That can affect badly your production. And as well, the time might be very different. This is an example of a quite small database, just going from an extra large to 2 extra large and from 400 gigabyte to 800 gigabyte storage, done under peak. So because if I'm doing that, it means that some alarm went wrong and there's some users on the database or something is going wrong on the database. And basically, the total time to do that change took about 12 hours. So for those 12 hours, I couldn't change anything anymore on the database. I couldn't basically apply any serious modification. And the change of the instance actually took from the logs just 13 minutes. The rest of the time was just change of the storage and optimization of the storage. So it's elastic, but up to a point. You cannot really trigger so quickly and change it back or do it automatically as much as you want. So yes, you can create your own simple fake autoscaling, but it's not that straightforward. And well, you can even say, well, but still there are no risks. I can do it. Worst case is as good as before. I mean, okay, I apply the change, it takes 12 hours, but I might have to wait. But I mean, I was under heavy load, so I had to do something because you don't want to say to your CTO, well, I did nothing. I was just analyzing the logs. So you did something. And you might say, well, worst case, I'm just waiting for something better. Well, it's not really that straightforward. Because I would say the worst case scenario is when your database is running out of IOPS, because there's no real automatic vertical scaling like with an instance type, and you need to provision something more. The problem is, how long can you really bust? I mean, even in case of Amazon, you have some standard storage, standard SSD, you have some bursting opportunity that you can go for, according to the peak, for a certain amount of time above your threshold. But that's a certain amount of time, and usually it's a few minutes if things are going wrong. So when you running out of IOPS, basically what happens is your database cannot keep up, your latency usually go up, and your users are badly affected. So you might be tempted, okay, now I want to scale it. That's my autoscaling script that I did before. I can trigger it. But even if you go to the console, you see that there are a few warnings out there when you do it. With a general purpose storage, the first thing you know is if you try to do that doubling of the storage, it tells you basically two things. First is, well, it might take long. And the second one is your performance are affected while this change happens. And that means that if your database you are triggering this change because your database was already suffering, you might basically kill the database and make it worse at that specific time. So your automatic script not necessarily is going to be that great. Well, you might say, well, I'm cool, I'm in production, I'm using a more expensive provision IOPS. A bit better, but still the performance are still affected while the operation takes place. And the reason is quite obvious, there's no magic behind. What happens behind is the data is copied to a new driver for the passive master, and then there's the failover, and when that happens is basically you are competing for writing and reading on that disk with the operation taking place. So you might even see that if you have a peak at 3 o'clock in the night and you know that it's not a sustained traffic, you might be better off to do nothing sometimes than just trigger an automatic change to increase the storage. And that's why at the end I call that approach a fake autoscaling. So okay, we say, okay, let's exercise caution, but how can we really go? Is there any way to really go automatic? Is there really a way to go to something that we would like to call serverless? Well, serverless is kind of a weird word for a database. You might even think that for a relational database, there's nothing like serverless, because a server is still running behind, but it's not just how hard it is to do an autoscaling, but even think now with somehow things got worse in the sense that the flexibility that something like RDS offers you, it's making things much harder to manage. If you think about RDS now, you have 35 plus instance types, considering different classes and different sizes, You have different kind of instance for memory optimized, burstable, standard. And each one of them offer, of course, different CPU, different memory, different ratio between CPU and memory, different networking, different IOPS. So the combination are quite a few, and even choosing which one you really need and which one you want to do, and even which one you want to do in your logic to elastically scale automatically becomes quite complicated because, yeah, as long as you just do vertical scaling inside the same class, it's quite simple. But when you consider all the variables, it becomes quite complicated and fragile as well. But there's now many more options, and the new option that is out there is actually called Aurora Serverless. And what is Aurora Serverless? Aurora Serverless is a new version of Aurora, a separate version of Aurora, that is based again on the, at the moment, just on MySQL 5.6. And it's called it's basically an autoscaling configuration. You have an endpoint, again, and if you think about, as a developer, what you like to have is, I would like to call a database, I would like to call a CNAME or possibly not an IP address, but a endpoint, I call it, and that endpoint scales according to the traffic I generate. Why should I manage myself 35 plus instance classes or whatever else? I just want to have that my database scales according to what I need. Well, Aurora Service is a bit going in that direction. Basically, you pay for what you use. You can have downtime. Basically, when you don't use it, it goes down. You have easy scaling. That means that you don't have to define which class, which size, and how often you want to use the database. You can authenticate using IAM. So basically, you can integrate that on your database, or on your standard cloud operation. So it's kind of seamless in that sense. As I said, it's compatible just with, at the moment, with MySQL 5.6, and there's now a preview as well of Postgres. It's relatively new. I mean, the general availability of the MySQL version is just from last summer. And the way you use it, you still use it using your just standard JDBC or ODBC driver that you use in your product. So you can still just talk to your serverless database in the more or less same way you were using before. Now, what happens behind the scene? Behind the scene is basically still a server. There are still a few servers running. There's a proxy hidden that basically with some warm, ready databases for you indifferent. And the cloud provider is basically managing the scaling up and scaling down of your database for you. What does it mean? Well, there are some restrictions on that. First obvious restriction is they try to find a scaling point, because the very cool part, compared as well to what we were talking about before, is, okay, you can build your own scaling with all the limitations we talked about, but you still have a failover. That means that for a few seconds, because the way the failover works is they change the CNAME to point to your new database in RDS or whatever else. And for maybe a couple of minutes or less, your database is not available. Anyway, the connection you had open is going to be dropped, and you have to reconnect. Might be a problem, might not be a problem, depends on your application. In case of Aurora Serverless, the connection are not dropped. You just talk to your database. Of course, there's a delay when something happens, when there's a scaling. But the way scaling happens is needs to have a time to be able to scale. So if you have a long transaction in process, or any of your queries using some temporary table at disk, basically you might, or there's any table lock, the scaling up might not happen. So you start to have a few limitations in that sense. You don't control the trigger of the scaling point. So I think it's at the moment, it's 70% of CPU for a certain amount of time, I think 5 minutes, and 90% of the max connection use. Then you scale up, and I don't know the logic to scale down, but more or less everywhere. And you might say, well, it's not really serverless Aurora, it's an auto-scaling Aurora. So they address the problem of how to run a database without having to scale yourself up and down your instance type. That's already a very big step forward. To really be serverless for many people, and in some sense I tend to agree, is they now offer as well, because until this point we are still talking about using a driver to talk to your database, open a JDBC connection or whatever else. You're not really going to the console and make a query. Actually, there's that opportunity as well. You can now talk to your serverless Aurora and do your MySQL queries just using a HTTP request and doing there's an API, there's an endpoint, and you So basically, you can integrate, for example, with a Lambda function. You can integrate with any backend where you want to use HTTP, integrate any other external endpoint. Is that really super exciting? Well, there's as well price point. There are some aspects as well that are quite convoluted. Like, for example, if you don't use it, it goes to sleep and you don't pay for it, but you have to accept that the first connection that is going to wake up the database might take up to 5 seconds. Is that okay? Well, it depends on the use case. There are many use cases where that is fine. There are use cases where that's entirely not acceptable. But there are many scenarios where you might already have really benefits from that. Think about if you have database where you just need to do some reporting, or where you have really unpredictable load for simple projects that are live for small audiences or for beta testing or whatever. Almost all internal development using development and test scenario, you can easily integrate it in your pipeline or whatever and have a database that runs is already loaded with the data, but it runs only when you need it, and you can call it using just a HTTP endpoint. Or generally environment where you just need intermittent load. Of course, if you have a production database where the load is more or less predictable and quite not fluctuating so much during the day, well, there's no much advantage in using a serverless option of Aurora. We are there yet? No. I mean, the goal, the dream of being able to run the database as I'm running the EC2 autoscaling group, or I run my cluster. Can I do that at the moment with databases? Not yet. I mean, there are still limitations. You're still not able to scale horizontally unless you do your own sharding, or unless you put framework in place in front of it and you manage the entire cluster yourself. But we are really getting into that direction. With that one, thank you, and I'm open for questions.